a team of British and American scientists is expected to announce that it has finally detected ripples in the fabric of space itself.
Yes, they're called gravitational waves. First proposed 100 years ago by Albert Einstein, could allow us to see what happened in the moments after the Big Bang.
Now, Dr Deepali Lodhia is an astrophysicist from the At-Bristol Science Centre and joins us now. Right, you are going to make all of this clear for us. And morning.
I'll do my best.
Let's start with, there is a big building, isn't there, that has these two big laser rods that wants to examine these waves that are coming to Earth. What does this do?
Okay, so what we see here is what we call Advanced LIGO. It consists of two very, very long arms. So each long is 4 kilometers long. There are laser beams inside, so they're bouncing back and forth between some mirrors. And what we're hoping to see is a change in length between those two arms, because gravitational waves, they stretch and squeeze space, and that's why we've got these detectors shaped like this.
So the gravitational waves are measured as they come towards the Earth.
That's
Is that right?
Yes, so as they travel towards the Earth, they're stretching and squeezing space and time, and alternately as they're travelling down around them.
So how are these gravitational waves created in space?
They are created by very massive objects, let's say an exploding star, which are called supernovae, or even neutron stars, black holes orbiting each other. So what we have to do is imagine that we've got space and time all condensed onto a two-dimensional fabric sheet. We call that the fabric space-time. And if we've got these two orbiting black holes, it causes ripples coming out of a sheet, a bit like if you throw a stone onto a pond. You see these ripple effects. Those ripples are the gravitational waves.
So Albert Einstein was way ahead of his time in so many ways, but it's 100 years, and he had the idea, but it just hasn't been provable. Is that where we're at?
That's right. So he theorized that these gravitational waves do exist. And even when we started observing binary stars, we noticed that they were losing energy in the form of gravitational radiation. But we've never managed to make a direct detection. And that's why this announcement today is so exciting, because we have improved our current gravitational wave detectors. They are so much more sensitive now, and they were switched on in September and they've been taking data.
So what are they going to tell us? What's the point in knowing about gravitational waves? I know you're very excited about it, but what would I get from it?
Gravitational waves, if we're able to detect these, it will open up an entirely new window through which we can observe our universe. At the moment, we rely on the electromagnetic radiation to observe our universe, so using visible waves, X-rays, radio waves. But as photons travel through space, they can lose information. But gravitational waves retain
information about what? Like what, the Big Bang, for example? Can we go as that far back?
Yes, so we'll be able to go right back to the time of the Big Bang, and even looking inside black holes and trying to work out what's really going on inside there.
What's that thing?
So that thing is demonstrating what happens to space-time as a gravitational wave travels at the speed of light. So it's going along, let's say, the z-axis, and then it's stretching along the vertical axis and then squeezing along the horizontal axis, and then it keeps alternating, and that's what happens. But of course, you can't measure this with a ruler, because the ruler will also expand as well, and that's why we're using laser beams.
You've got those two rods to measure the vertical and the horizontal.
Exactly,
like,
yes.
At an angle like that. 4 kilometres long.
Yes.
And big lasers.
The problem is that these waves are so weak. So even though we've got these 4 kilometre long arms, we're looking for a change in length which is smaller than the diameter of a proton.
So we find out later on?
We will, yes. Fingers crossed.
Thank you very much.
Thank you.
Do you get it?
Sort of. Sort of.
So
I get that the big arms are going to measure something coming down, and yeah, I think.
So if you went to a party or dinner tonight, you could explain.
No, I'd pay a lot of attention to the food. I'd say that I love prawns. That's my favourite.
You'd be thrilling company. Oh dear. Coming up on the BBC News Channel Business Live is going to be on Here on Breakfast. Well, Nick Clegg has called it a national scandal, the felling of thousands of trees in one of the UK's greenest cities. We're going to find out about a battle that's being fought to save them in the High Court.
Time now to get the news, travel and weather where you are. We'll see you in a few minutes' time.
Prawns, gravitation.
very good morning.